By 2026, technology will not just change how we live, it may determine whether we survive. Some breakthroughs could extend human life. Others could transform our planet or even threaten it. Here are 14 technologies already in development that could change everything. Number 14. Converting air humidity into electricity. Researchers have developed thin, flexible membranes that generate electricity directly from moisture in the air. Built using protein nanowires, these films can produce a steady flow of low-voltage power without batteries or sunlight. Early prototypes already power small devices, and results suggest scalability for wearables, sensors, and remote systems. Because the material is compostable and requires no moving parts, it could bring renewable energy to almost anywhere. This is a step toward distributed power drawn passively from the environment without traditional grids, storage, or fossil fuels. Number 13. Mapping the universe in real time. In June 2025, the Vera-C-Rubin Observatory captured its first ultra-deep images using the world's largest digital camera, with 3.2 gigapixels. In just 10 hours, it identified over 2,000 previously unknown asteroids. Starting later in 2025, the observatory will scan the southern sky every few nights for a decade, tracking supernovas, asteroid orbits, and potential Earth impact threats. Scientists expect it to detect around 20 billion galaxies and more than 100,000 near-Earth objects. By producing a continuous time-lapse of the universe, it will transform planetary defense, astronomy, and our understanding of dark matter and dark energy in unprecedented detail. Number 12. Artificial photosynthesis. Artificial photosynthesis mimics the natural process of plants but at far higher efficiency. Using sunlight, water, and carbon dioxide, experimental devices are able to produce liquid fuels, plastics, and industrial chemicals. Some pilot plants are already capturing CO2 from the air and converting it into carbon-neutral jet fuel. Unlike natural photosynthesis, these systems can operate year-round and scale for industrial use. Researchers believe this technology could decarbonize aviation, shipping, and manufacturing while reducing atmospheric carbon dioxide. If deployed globally, it could help replace fossil fuels for entire industries. What once existed only in the lab is now moving into commercial trials across several countries. Number 11. Programmable matter. Scientists are developing programmable materials that can change shape, texture, or even function on demand. Early prototypes use micro-actuators, magnetics, or responsive polymers to alter their physical state within seconds. Imagine a flat sheet that transforms into tools, drones, or mechanical components without traditional manufacturing. In robotics, this could mean machines that adapt their form to different environments. The military and space industries envision equipment that reconfigures itself in the field. Consumer applications are still years away, but progress in soft robotics and reconfigurable materials shows that physical objects may soon become as editable as digital files. Number 10. Organoid intelligence. Organoid intelligence uses lab-grown clusters of human or animal brain cells, miniature brains, to process information. Unlike silicon chips, these living neural networks learn and adapt using biological efficiency. Researchers have already trained organoids to perform simple computer tasks and respond to stimuli. The appeal lies in energy efficiency. A human brain uses just 20 watts of power, far less than today's AI supercomputers. Potential applications include ultra-efficient machine learning or hybrid biological digital processors. At the same time, the field raises ethical debates about sentience and consciousness in lab-grown tissue. Current research focuses on improving training methods and scaling neural capacity while staying within ethical boundaries. Number 9. Fully autonomous AI agents. Fully autonomous agents are systems that operate without direct human input. They set their own goals and carry them out end-to-end using natural language interfaces. These agents can manage research, code software, trade stocks, or even oversee supply chains independently. Unlike traditional AI tools, they adapt to changing conditions in real time. Prototypes like Adopt and Devon have shown limited autonomy, but enterprise versions are already being tested for 2026. The risks include transparency, security, and the possibility of unintended objectives. As autonomy improves, strict oversight mechanisms will be essential to keep them under control. Number 8. Extreme environment robotics. Robots are being designed to master tasks in minutes instead of months. Using advanced reinforcement learning, they quickly adapt to new environments. Models like Figure 02 and Agility Robotics Digit are already entering industrial trials. Deep-sea and nuclear site robots are undergoing testing in extreme conditions, operating where humans cannot in high radiation, deep oceans, or even space. Fast learning reduces costly retraining and downtime. In 2025, prototypes learned assembly tasks overnight and navigated hazardous terrain autonomously. In the future, these robots could handle disaster recovery, exploration, and defense missions without risking human lives. Number 7. Large-scale LEO satellite internet. Mega constellations like SpaceX's Starlink and Amazon's Project Kuiper are deploying thousands of satellites in low Earth orbit to deliver global high-speed internet. As of mid-2025, Starlink already operates more than 6,000 satellites, reaching 75 countries. These networks aim to connect remote regions, ships, and aircraft without traditional infrastructure, while also improving Earth observation, disaster response, and defense. Concerns remain about orbital debris, space traffic, and geopolitical control over communication. But by 2026, coverage is expected to expand sharply, reshaping global access to information and strengthening strategic communications. Number 6. Sustainable aviation fuel. Sustainable aviation fuel, or SAF, made from captured CO2 and renewable energy, is moving from pilot programs to industrial scale. Processes like Fischer-Tropsch synthesis use atmospheric carbon dioxide and green hydrogen to produce liquid hydrocarbons compatible with today's aircraft engines. In 2025, plants in Europe and North America began producing commercially viable volumes, and airlines such as United and Lufthansa have already conducted successful test flights. If scaled, this could significantly reduce aviation's carbon footprint while recycling atmospheric carbon. Challenges remain in cost, production, and renewable power supply, but momentum is growing toward large-scale adoption. Number 5. Quantum AI. Quantum AI merges the power of quantum computing with machine learning. Quantum processors can explore vast numbers of possibilities simultaneously, making them ideal for optimization, drug discovery, and complex modeling. In 2025, IBM, Google, and startups announced progress in error correction, which is critical for reliable quantum operations. Though still experimental, quantum-enhanced AI could eventually outperform classical AI in chemistry, logistics, and cryptography. One major concern is cybersecurity, since future quantum systems could break current encryption. Governments and companies are already racing to develop quantum-safe cryptography before that day arrives. Number 4. Self-growing engineered living therapeutics. Living therapeutics use engineered cells or microbes inside the body to detect and respond to disease in real time. For example, engineered gut bacteria can sense inflammation and release anti-inflammatory compounds. Trials are exploring treatments for diabetes, cancer, and metabolic disorders. Unlike traditional drugs, these living systems can persist and adapt, potentially replacing failing biological functions. Researchers are also developing programmable cell therapies that can be updated like software. While early studies show promise, questions remain about safety, control, and long-term immune response before these treatments can become widespread. Number 3. Implantable brain-computer interfaces. Brain-computer interfaces, or BCIs, link the brain directly with computers for two-way communication. Companies like Neuralink and Synchron are testing implants that allow paralyzed patients to control devices using thought alone. These implants can record neural activity and stimulate brain regions to restore lost function. Potential applications include memory enhancement and even direct brain-to-brain communication. In 2025, human trials expanded, showing reliable cursor control and text generation purely through thought. Challenges remain around surgical risks, data security, and implant stability, but steady progress is pushing us toward deeper human-machine integration. Number 2. Real-time AI-driven disaster prediction. Artificial intelligence is now being combined with satellite imagery, remote sensing, and weather data to predict natural disasters with unprecedented accuracy. Platforms like Google's Flood Hub and IBM's AI weather models can forecast floods, storms, and heat waves days or even weeks in advance. New projects are integrating seismic data for earthquake and tsunami prediction. In 2025, AI systems successfully provided multi-day cyclone alerts in the Indian Ocean and wildfire spread forecasts in California. The next step is expanding these systems to regions with limited infrastructure, where faster warnings could save thousands of lives. And finally, number 1. Cryogenic preservation and revival. Cryopreservation is advancing beyond cell storage to whole organ freezing and revival. Vitrification techniques now prevent ice damage, allowing long-term storage of kidneys, livers, and other organs. In 2025, researchers successfully revived preserved rat kidneys and restored their function after transplant. Long-term, this could extend to whole-body preservation, with applications in space travel and life extension. While human revival is still speculative and far from reality, organ preservation breakthroughs are already transforming transplant medicine. One day, indefinite biological storage and eventual revival may be possible. The future is not decades away. It is unfolding right now, piece by piece. These 14 breakthroughs show just how close we are to a new era of technology that could shape not just our world, but our survival.